Now we're going to take a look at Minitab in terms of the one-way Anova function. This function is comparing for one y a number of different x's, and remember it's comparing to say, are the means of each of those logical subgroups any different one from the other? The data set we're going to take a look at here is azalea. This is a data set that came about from the growing of azalea flowers and taking a look at different treatments that occurred in different locations and different amounts of fertilizer. So let's take a look at the data and see what it tells us. Well, the multivariate analysis we said was a graphical ANOVA. So now let's talk about how do we actually do the one-way analysis of variance. In Minitab, we'll find this function under stat, where all of the things are ANOVA, and it's this very first option here, one-way ANOVA. Now, one-way ANOVA means there's one y as the performance measure, and then we have different rational subgroups that we want to look at and see how does that performance measure change as a function of those different rational subgroups. So those subgroups may be process steps, they may be pieces of equipment, they may be individual factories, or they may be people. So we take a look then at the variation within each of those subgroups and then the variation between. And the one-way ANOVA is testing to see, is there some difference in at least one of those rational subgroups to the rest? So if we select this one-way ANOVA, okay, we'll see that we have a selection here. Is the response data in one column for all the factors, or is it in multiple columns? So here we see we're going to select multiple columns. And so the response that we have for this is going to be C1, so it's these first 5. Okay, so what I did was now to put all of the data in there, I held down the Shift key and I clicked on the first one and then clicked on the last one in the set. So as I hold it down, see, as I hold it down, I can click like this and get all of that data in at once. So that's what I did. Now, graphs, we come to this one, and let's select not the interval plot, but the box plots. So the interval plot gives us the wrong expectation about performance. I want you to be able to do this graphical analysis, so we'll always choose the box plot as the one we want to choose. Now notice we'll see here that the residuals plots, we only get what's called a 3-in-1. And so we'll come back and we'll talk about residuals analysis at another time. Okay, so we have this data and we click OK. And here's what we get. Okay, so we get a graphical output and then we get an output that is also in the session window. So as I take a look at the session window, what I will see is the session window gives me this data. Okay. And I see that I have an analysis. So it says all the means are equal. That's the null hypothesis. That means all of the subgroups came from the same population. And so the alpha to detect is a difference of 0.05. The alternative is at least one mean is different. Okay. And here we have the p-value. It's 0. So that says there statistically is a significant difference between at least one mean and all of the others. And we see the r-squared value, so r-squared adjusted is the number we want to choose, and that's 84.175. That says this is explaining 84% of the data that we see in this data set, just by the fact that there are these different weak items that are chosen. And then we see the means and the standard deviations. So if I want to understand a little bit more about what's happening, I should take a look at the box plot then. So the box plot then shows me that there is at least one difference. Now what I see is actually week 1 and week 4 are pretty similar. Weeks 2, 3, and 5 are pretty similar. And so what I see is there's at least a difference between week 1, between weeks 2, 3, and 5, and also week 4 between 2, 3, and 5. But weeks 1 and 4 are pretty similar, and weeks 2, 3, and 5 are pretty similar. So here's the variation within the week, and then this line that's connecting them, that would be the same as the multivariate line. So that is connecting the averages, and that is the between variation plot that we would see. So this is the main effects plot, or the effect of variation changes with subgroup. And here we can clearly see that there is a difference. So that's why we get that 0.000, saying there's a statistically significant difference. Now, the value of this is we can start understanding which one is better. So for instance, data here is the output, but that data actually represents a measure. And so that measure, if it was like growth, this data set that was originally called azalea, and it's about the growth of flowers. So do we want more growth or less growth? Well, I think the answer is more growth. So a bigger number here is a better performance. And so what we see is that each of these is a different geography, it's a different sample, it's a different set of soil, and a different treatment in terms of fertilizer. It had different rain, it had different sun. So now I see I have 2 samples where I had something big happening in terms of growth, and 3 where it was much smaller growth. So what's the difference between best of the best and worst of the worst? So if I click on this box week 1, we see that it's different. And I can edit now, I click on it 2 times actually. Now I can edit this interquartile range. So I right-clicked on that twice. And then I go to Custom and Type. It allows me to put like a crosshatch on it. And Automatic, it allows me to color it. Okay, so I choose a red color. And I say, oh, that's different. But this one was also different. And so if I click on that now in the same thing and I edit it, I can also put in the crosshatch. Custom, crosshatch, automatic color, red. So now I see these 2 are different, okay? And I can click here on the title. So if I edit this, this is right-clicking. If I edit this, what I see is I can change the title. And so this is azalea growth. By week and location. Okay, so that makes more sense. Data doesn't make much more sense. If I right-click on it and I change the label, instead of data, I can say growth in centimeters. And if I start taking a look at this, now the chart's starting to mean something. And it's now a way for us to say, we have more growth here, and now what we're curious is, what's the difference between the reds and the blues? Okay, so now we haven't reached the end of our analysis options here, but we now know what we want to do next in our exploratory data analysis. We want to find out the difference between the best of the best, week 1 and week 4, and their locations, and the week 2, 3, and 5 locations, and what makes the difference with those. Why were they worst of the worst? Why didn't they have the growth? So again, this is again a very good tool for us to use in exploratory data analysis to see where are there differences within the data sets, within the rational subgroups, or between those rational subgroups. So let's take a look at this as a tool that we will flexibly use throughout all of our different types of analyses. We'll continually come back to this, and every time we have the data set, if I go in and I want to understand what's happening here, I might ask the question, what is actually happening here? So if I want to take a look within there, I go to that group and then take a look at the rational subgroups there and say which one of those actually is changing the most. Well, after looking at azalea, what we can see is, yes, the data wasn't quite normal. No, it wasn't actually equal variance, and there were some problems there. But what we see is we can get a useful result. And for engineers, that's the most important thing, a useful result that allows us to focus on the next set of questions that will drive us closer to what is the root cause in the circumstances, which factors really matter. And so the one-way Anova is an acceptable tool for a green belt to use. Now we'll start seeing at a black belt level, there are other different types of analysis of variances that can also be used. So if you feel like you're getting stuck, if it doesn't feel like this is the right tool for you to use because your problem is more complex, what I recommend is talk to a black belt and see what additional tools they've used that might help you in this circumstance.